So we're going to get started. Thank you everyone for joining this webinar today. Today's webinar is hosted by HashiCorp's Field CTO, Brent Holden. Brent will go over the cloud operating model and how you can align people, processes, and tools to achieve the most value in a multi-cloud environment. I do want to note that the last 15 minutes of this webinar is dedicated to Q&A. So if you have any questions, make sure you put questions in the questions box and we'll get to them at the end of the webinar. I do also want to note that this webinar is recorded and we will send out the slides and the recording usually 1 or 2 days after post-processing. And so with that, I'm going to hand it over to Brent. Brent, off you go.
Oh, thank you, Lynn. I appreciate that. Hi, everybody. Thank you for joining me today. My name is Brent Holden. As Lynn mentioned, I'm HashiCorp's Global Field CTO. That means generally I have to partner very closely with our CTO, Armin Dadgar, and Mitchell Hashimoto, as well as being a technology leader in the field, talking to primarily executive customers about HashiCorp's technologies, the adoption patterns, as well as some of the technical bits that come along with them. So again, thank you for spending some time with us today. I want to go over what the cloud operating model is, how effectively to unlock it, hence the title of the presentation, and what that means for, I think, the different technology stacks within different units within IT of your company. So I'm going to turn off my video just for a few minutes so you can help focus on the presentation. Fortunately, I've got a face made for radio, not television. Okay, so let's talk about the company very briefly. I mentioned Mitchell and Armand are the co-founders. They're also co-CTO. And it was sort of their ethos, the company, that they thought primarily about workflows over technologies. I know that sounds weird having the technology stack sort of presented in front of you. It's really important that each of these technology stacks focuses on a workflow and has a technology agnostic backend. That is just a very core part of the ethos, and it's just something that they take very seriously when it comes to creating an ecosystem around each of the products. The technologies themselves, I'm not going to read off the list for you. The ones we're going to focus on today are primarily Nomad, Consul, Terraform, and Vault. Packer and Vagrant, although very important to the development community, are not something we're going to spend a lot of time talking about. The reason for that is primarily because each of those different technologies forms a part of what we like to think of as the cloud operating model, as part of a shared services offering that IT can deliver internally to your customers. We're going to talk about what those capabilities are today. So I think the best way to think about it is to think about how the world has changed. The world's a lot different than it was in 1998 to 2008. The advent of cloud, sort of in that period. And now over the last decade, public cloud has taken on a sort of a world of its own. Now it's not that the infrastructure that you already have today is going to go away. It's that now we have to start thinking about what this transition looks like. Also, what are the additional problems we have to think about? So what we see generally is we see this sort of movement from on-prem dedicated infrastructure that's very static. You provision it once, you don't really think about it after that. Those data centers are not necessarily going away. Now, I've spoken to very, very few customers over the last, say, I don't know, maybe 5 years or so. Very few customers are building new data centers. It's just not really a target for most companies. It's expensive. It's just doesn't deliver a lot of value, especially with things like public cloud, where each of them are starting to provide services around a niche. So I think like when we think about the adoption patterns we see, customers are sort of slowly gravitating to AWS and Azure for sort of general compute around both Linux and Windows, as well as things like GCP around data processing workloads. And so our view of the world is that chances are you're going to be a multi-cloud company. Now, whether or not you think of yourself as private plus AWS is inherently multi-cloud, it could be that you acquire another company that maybe your company is based in Azure, but this other company is based in AWS. Congratulations, you're now a multi-cloud company. So I think that there are some other inherent driving factors to sort of combining all these services and trying to reconcile them all. Now, I think the most important part, I should say, around the the shift from your traditional data center to public cloud and having this multi-cloud environment is the inherent process shift. Now, the ticket-based sort of processing mechanisms internally for most companies, that's just the standard way they do business. If you want, let's say like a 3-iterative application deployed, you talk to your compute team, I need some general app servers. And you talk to your database team, I need some database servers. I need some load balancers in front of those, and I'll talk to your load balancer team. Then I have to talk to the firewall team. Then, maybe in addition to that, there's other services. Some companies that we've talked to have roughly 72 of those ticket-based steps associated. From the end consumer of that type of process, it's an absolute nightmare. Now, I think what the world wants to move to is, call it DevOps, call it CI/CD oriented. We tend to think about it in terms of, at the end, we're really providing self-service. So it's really that shift away from being the technology gatekeeper to being the technology enabler. Now, we're going to talk about a few things specifically when it comes to Terraform of how we're going to be able to do that. I'd say, generically speaking, the biggest change that I can see within the industry is that we're moving from each one of these technologies, has a team that understands the complexities of the technology, and they may expose an API that's not really consumable by the different developer groups because they have to understand all the nuances of the technology, to how do we present sort of an easily consumable API on top of these different workflows. So I mentioned from the beginning that HashiCorp is very workflow oriented. So how do we provide sort of a provisioning workflow or a security workflow or a networking provisioning workflow, and how do we solve those problems? So the second sort of shift that we see is that there's going to be this sort of what I would define as systems of record, which are the old hairy applications that sort of live on-prem, whether those are Oracle databases or ERP systems, e-business, SAP, PeopleSoft. There's a certain type of system that's very long-lived, and it's not going away anytime soon. And those are being augmented by the different services we're going to provision on, either private cloud or public cloud infrastructure that are systems of engagement. Think of it as, the systems of record where all your data is stored, all your customer data. That's a really important apps that drive your business. The systems of engagement are maybe the tens or hundreds or potentially thousands of apps within your company that sort of drive the company, but none of them unto themselves are sort of necessary to run the business. Okay, so let's sort of like decompose some of the challenges around what that cloud operating model means. Now, for provisioning, most people are used to like this very sort of homogenized environment. Maybe they're used to a VMware, Nutanix, OpenStack type environment where things on-prem are just dedicated. They're not going to change. They're provisioned once. Versus the dynamic model, which is more capacity-based, and it does tend to be more heterogeneous. You see that the standard unit of security here is really around IP. We're going to talk about that when we get to the networking portion. And really that needs to shift towards more of an identity type of security. So that's inherently like what's driving a lot of the security-based challenges. Now, you have these traditional networks where the controls that you manage were really firewall rules around those IPs. When you have these highly dynamic environments, it really needs to shift to being identity-based because those IPs are going to change constantly. And because of that, we're really thinking about networking and sort of firewall configuration instead of like being these static things that never change, and your firewall rule configuration is sort of this append-only list of just things that get added, and it's sort of this Jenga, playing the game of Jenga of like, well, if we change something, is it going to impact other services? To now we have to assume that things are going to change and things are going to have to, the controls are going to have to sort of move along with the services. And so we have to start thinking about what are the intents of different services communicating to each other and sort of managing those dynamic controls associated with them. I think the last thing is really around scheduling applications. For most applications, you sort of set it and forget it. You deploy the app, and deploying apps continuously is just a all hands on deck. It's a 2-week process, and you do it like maybe once every quarter or once every 6 months. versus this dynamic, you're scheduling apps and then you're scheduling blue-green deployments, you're sort of managing your application as a fleet service. And so I think if you sort of pull apart the different technologies associated with that, for the provisioning, things that we have to think about are how do we provide sort of private cloud provisioning, but then we also have to sort of tie in these different resources, CloudFormation, ARM, as well as Cloud Deployment Manager on Google. When it comes to security, same thing. Each of these different security identities, each provider has their own sort of identity. None of them mean anything to each other. I think it's a really important point. When it comes to connecting the different services on-prem and making them discoverable, each service is sort of providing their own, service mesh, whether that's app mesh on AWS, whether that's Istio on GCP. Azure has a very new offering in that space as well. And the last is sort of how do we deploy applications? I think like most applications deployed today are more based around how do we deploy an application instance versus in the future, we're going to start thinking more in terms of how do we deploy containers of applications that are portable across infrastructure, as well as how do we deploy functions as part of our functions as a service environment provided by Lambda, Azure Functions, or Google Cloud Functions. Okay, so sort of jumping into what that means for HashiCorp, how we think about the problem, we sort of decompose it into these multiple layers, and then how do we connect these layers in a meaningful way? And so let's sort of walk through how we sort of adapt to these shifts in the technology sphere that we've outlined, as well as providing compelling APIs at each layer. Now with Terraform at the infrastructure layer, it's really around how do we sort of help onboard technologies into these different cloud environments. What I see is that we have a lot of customers who sort of figure out how do we do things off-prem and then bring those skills and that process workflow back on-prem. And so when it comes to things like AWS and Azure, GCP, we do have, we work with customers that are investing in each of those different technologies, whether it's CloudFormation or ARM. But really, the reality of sort of being a multi-cloud company hits very quickly. And it's really important to think about infrastructure as really this API that you're exposing as a centralized service and making it very easily consumable. I think the phrase that we have here internally is you want to make the paved path the easy path, right? And so I think the challenge is that you don't want to have developers sort of trying to figure out how do we consume AWS APIs and Azure APIs and GCP and private cloud, be it VMware or vSphere or what have you. You want to be able to provide a very simple workflow and a very consistent API to interface. So that's really around like what is Terraform. Terraform is sort of the concept that you're sort of leveraging this provider model. Now, how I've best heard it described is really around the Microsoft driver model. I think a lot of people have these questions as to, well, how do we sort of maintain all these different providers with Terraform? And I think the reality is each of the different cloud providers maintains their own sort of plugin for Terraform, and then each of them iterate on it themselves, and they provide updated capabilities as their cloud offers additional capabilities. So that allows each of them to sort of fit into this common API and workflow while still exposing all the things that make their platform unique. And I think that's a big reason why Terraform has really caught on very strong in the market, is really around allowing those unique services to be consumed, but providing that consistent workflow. Now, if we think about that statement I made earlier of how customers are really starting to adopt not just public cloud, but also on-prem. When you talk about public cloud, well, really it's like you could use the AWS sort of provider to consume a sort of myriad of AWS services. The same is not true for on-prem. For on-prem, you could be talking about having like a Datadog or a vSphere or an F5 or Palo Alto Networks. That sort of API compatibility layer is super important there, because what happens is you have this proliferation of APIs, especially on-prem. All these different vendors, they've all decided the best way to sort of expose their different capabilities. None of them are consistent. And so having a very consistent way to consume inconsistent API structures has a lot of value for the workflow. And so a big emphasis of the Terraform team is how do we enable different providers to sort of participate within this ecosystem? And as of today, to my knowledge, there's over 200 providers for these different sort of both on-prem and off-prem public cloud, different providers, whether those are SaaS or PaaS or IaaS or even bare metal. We have to think about the different infrastructure at different layers, and we have to sort of provide API services around those. And I think one thing that's sort of really important to think about is how the single Terraform template is a way to define infrastructure and define the relationships with each other. And the reason that's important is because it allows you to define infrastructure as code, but it also gives you a state that sort of lives with the infrastructure and allows you to understand how are these different resources interconnected with each other. So you provision them as ones and you decommission them as one. And that's a really important, I think, point to sort of consume, which is one of the bigger challenges of deploying applications for most customers is they deploy each one of these technologies independently of each other through their ticketing systems, but no one's ever really keeping track of firewall rules or load balancers or anything that goes along with their application. And so over time, you sort of build up this cruft in your infrastructure, especially when it comes to firewall rules. Very few customers that I've seen have ever removed a firewall rule because they're just not sure if it's going to break an application or what's going to happen afterwards. So it's really important to sort of think about how do we maintain these things cradle to grave. Now, I think the overall theme for Terraform is really around how do we provide this sort of self-service provisioning environment, effectively the provisioning team exposing an API for consumption, and then allowing operations teams to enforce the security and policy at the provisioning time. Now, I want to spend a couple minutes talking about that because I think that that's probably one of the bigger sticking points for a lot of customers in the adoption patterns, which is, okay, it's great, like I gave all these developers self-service and now they completely ran amok. They're deploying systems that, they are expensive, they're not keeping track of them, they're not decommissioning them, or they're just exposing resources that they just shouldn't be, whether that's like an M4 extra large on Amazon, or maybe that has something to do with like a GPU associated resource on top of Google that's very expensive. And so it's really around, part of it's containing cost, but part of it's also retaining compliance capabilities, which is really why we sort of thought about what was this, a policy as code engine that we could build. I think one thing that we don't really talk about, at least on the deck, which is why we built it. And when we think about how customers have deployed this historically, they provided this self-service API, it plugs into all their infrastructure resources, whether it's Amazon or on-prem. And then what happened with some of our customers is that they get to this state and they realize that there's no policy controls on top of it. And so they create effectively a queue that sits in front of the provisioning process. No, excuse me. Your success as a company is not going to be tightly coupled with that group just because that's a very limited amount of resource pool that's sort of reviewing for compliance and policy. You may have between 5 and 10 people if you're a very large company, which is going to hold up those deployment processes for months. So yes, you sort of fix the problem in that you have this one API that's sort of extracting away all these other sort of non-generic APIs into a really consumable model. But then when you go to deploy resources, all of a sudden you have a human in the mix that's sort of hitting the checkbox for, is this going to cost us a lot of money? And is this an appropriate thing that they should be deploying? And what we found is that it was super important for HashiCorp to sort of build in a way for a risk and compliance group to be able to participate within infrastructure to sort of define rules. And as infrastructure is deployed, it checks against those rules. And if it passes, it's good to go. If it doesn't pass, it throws an exception and lets people know that it has to be reviewed. And I think that that ability for sort of a risk and compliance group to participate within infrastructure, if you're a large regulated entity, they're going to have to participate. And the question is, how do we sort of automate that and take their policy and put them into code and make that as easily to consume as possible? That's really where a lot of our customers have driven success. So that one customer I talked about earlier, they had roughly a 3-month deployment process, it was roughly 12 weeks. With Terraform, they were able to slim that down to 6 weeks because not only did they use Terraform, but they had a human at the end reviewing compliance. After the fact, they slimmed it down to 5 minutes. Right? So I think like there's a very clear identification of a problem that we're trying to remove as many humans as part of the mix as possible. Sort of jump to the next layer, which is around Vault. Now, Vault is the security product of HashiCorp. Also provides this really a really valuable service in that it allows customers, as they're moving towards different deployment models, to start pulling out things like secrets out of code and start offering things like encryption as service. And so let's talk about it for a few minutes. I think the traditional access model, when you talk about systems, is you're going to, as a client, you already have credentials that are hard-coded by your database team. They're going to hand them to you when you deploy your application. Chances are those credentials sit in the source code, which is just something that makes it really difficult for companies to either rotate those credentials, or it makes it really difficult for customers to have a highly secured environment, because as long as those credentials are in your source code repos, anyone who has access to your source code repos also has access to your data. And so we need to sort of shift away from this traditional access model where I think the idea is to insert Vault as a centralized service and make it part of the workflow. So that way, when clients come in, let's say this is an application where it's a database service, and it says, hey, I'm a database service. I need a database, or whether maybe it's an application service that needs to have access to a database service. It says, hey, I'm a web service or an app service. I need to have access to this database instance. Give me access to it. It's really speaking to Vault and authenticating against Vault to say, I am who I say I am. And Vault is checking to see, do you have permissions to access that database resource? And if you do, I'm either going to give you credentials that I've already generated for you that are long-lived, or I'm going to dynamically create those credentials for you and deliver them back to you. And so that's really sort of the inherent shift in the model, which is instead of interacting directly with the database for authentication purposes, you're really talking to Vault. You're using Vault as your intermediary to then deliver database credentials for you. So when it comes to having policy that's enforced, it's really around leveraging Vault's ability to sort of act as that middleman and become an identity broker for sort of who can talk to who. Excuse me. One thing that we don't really spend a lot of time talking about with Vault is that one common pattern that we see is that, with that shift to sort of being multi-cloud, you may have resources that sort of live on-prem that maybe they need to speak to resources in AWS, or maybe there's resources in AWS that need to speak back to your systems of record on-prem, or maybe it's any combination thereof of Google resources need to talk to Amazon resources or likewise. And I think the inherent problem is that each of these different sort of cloud providers has their own identity pattern, whether it's IAM with AWS, IAM with GCP, AAD with Azure, Active Directory on-prem. None of these credentials mean anything to each other. And so it allows Vault to sort of be the broker of, if I'm a client and I need access, I already have this token, maybe I've already authenticated against IAM, or I have an IAM token. It allows the client with an IAM token to say, I need access to a resource that's governed by Active Directory, and Vault can be that intermediary to allow you access to that system. So it's not necessarily just about access between applications and databases. It is about access from application to application or application to data that are sort of governed by different identity resources. All right, and so like the two things I mentioned sort of to start with are the two biggest use cases for Vault. The first is sort of pulling out centralized secrets management into this centralized service. And what we mean by secrets management, that could be anything. That could be a database password, that could be SSH keys, that could be, really sort of anything that you don't want other people to have, even PII. And so, so the first goal is to sort of pull that out of source code and make it something that you have to request when your application is provisioned. The second is offering encryption as a service. And I think the biggest problem that I see is that a lot of customers sort of rely on transparent disk encrypt to be able to do that. Transparent disk encrypt is not sort of the panacea of security. In fact, I would venture to say that transparent disk encrypt, the threat model protects against is someone walking into your database or walking into your data center and pulling out disk drives from your database server and then walking out with your customer data. That threat model is so exceedingly rare, especially when it comes to a public cloud environment when you may have millions of disk drives in an AWS data center, and it just doesn't make any sense, to protect against that threat model. And so the idea with encryption as a service is to, instead of throwing unencrypted data out from application to database over the wire unencrypted, it allows you to encrypt up to a standard. And so your security and risk team could say, well, we need you to encrypt to AES 256. And the challenge with doing that from a security team is that they're not typically providing the how you do that. They're just telling you that you need to encrypt to that standard, and it's up to you to go figure it out. And I think the challenge that we've seen with a lot of customers is when they start consuming encryption is that each of these different application development teams have to implement that on their own. It ends up being a huge challenge for them. And the thing about encryption is that if you don't encrypt it 100% correctly, it is not going to be 100% effective, right? Either it's 100% implemented correctly and you're 100% effective, or it's not 100% implemented correctly and it's 0% effective. And so offering encryption as a service just allows you a way that as you sort of start adopting to these different platforms, it allows your developers an easy way to consume encryption, right? And so that way they're not worrying about what does the implementation look like. They can just encrypt data. It allows your risk and compliance teams a way to sort of manage what those keys look like and how they get rotated. Next layer we want to talk about is around Consul. And so Vault has a very different way of thinking about security. Consul sort of does the same thing. So some customers, when we talk about Consul, usually it's sort of adopted on a per node consumption, and Consul is really designed for scale. We have some customers running, north of 100,000 nodes today, and we're going to talk about why that is and sort of what problem it solves. Now, in the traditional networking model, it's typically that you have load balancers sort of live at the static IP, you have some sort of application deployed behind it, and there's a firewall rule sort of governing authorization. And there's a couple things that happen in these highly dynamic environments. The first is IPs change, or you're adding new services as part of an auto-scaling group, for instance. And as those services come online behind those load balancers, that could take multiple weeks to deploy an update to your load balancers so that way your new application server is effectively getting traffic. For most customers at 6-week time, I mean, that's sort of, for a lot of networking teams, that's sort of the optimal time. We have some customers that leverage Consul to then update their traditional networking structure and drive the automation for it to bring that 6-week time down to 5 minutes. So it's really about, how do we sort of live in this highly dynamic environment where new resources are being spun up and they're sort of driving automation around our existing networking environment. The second thing that really Consul provides is around having a registry of different applications. So it effectively allows you to discover if you have one application sort of sitting on one part of your infrastructure and it wants to discover services from another app or from another that it needs as part of its app, well then how does it effectively find those different services? And so what we think about is having that Consul providing that service registry. So as services get spun up, they register as a service, and as they're registering, new application servers against that service, they're updating their new IP addresses. And what that means is that instead of sort of referencing the IP address for everything, now allows us to switch to DNS, right, and using a name for each of these different services. It just makes it a lot easier to sort of, for east-west traffic, now all of a sudden, for most customers, they don't necessarily need a load balancer in the mix. The reason being that you're just automatically leveraging DNS in sort of a round-robin approach to then access services east to west. Now, for a lot of customers, they're not able to expose multiple IPs in their north-south infrastructure. So when it comes to their external customers coming in, they're still going to need a load balancer. But for like the east to west approach of how do we make things highly available? In a lot of ways, you don't need a load balancer. A load balancer is only handling, in a sense, indirection for high availability, and it's also sort of taking polling of, are these things still in existence and are they still alive? What's nice about Consul is that it sort of maps the service location to where it is, but it also allows you to update against, are these things still active? And it's sort of actively, all the nodes are sort of checking each other to make sure that things are still up and running. And so because of that, it allows you to route directly from service to service rather than going through like this sort of chain of firewall to load balancers. Now, in a lot of ways, you're probably not going to get rid of your firewall. That's for most, that authorization principle and that control of being IP related, that's going to be a hard thing for a lot of networking teams and a lot of security teams to sort of get rid of. And we're going to talk about that in just a minute, what that looks like. So with service registry, it's really around just creating different names for your applications to enable routing between them. Now, service segmentation is sort of a different level to that problem. So I mentioned that with different services, they're typically disconnected by both a firewall and a load balancer for indirection. Now, we can leverage Consul to drive automation for both firewalls and load balancers to help just update them in a more quick fashion. Now, I think the ideal is ideally for east-west traffic, you're getting rid of those load balancers, and then that means that your firewall is still the one sort of governing the authorization of this IP can talk to this IP. Now, sort of teeing up that problem of when you have different services that get spun up on these different platforms, talking through different IP addresses that change, we need to shift our thinking away from IP-based into more service-based, right? So it's more around how do we create a stronger identity for each of these different applications to sort of talk to each other and then upgrade their connection into mutual TLS, assuming that there are sort of this adversarial relationship. Now, the way that you'd sort of get away from having a load balancer in between these two is Consul allows you to maintain what we would call the intents of app server 1 is able to speak to web service 1, and the idea there is the point of having a firewall in between those two different services. It allows you to very strictly define this IP address can speak to this IP address. When IP addresses don't matter, firewalls become a lot more difficult to wrangle and manage, and so having those different identities and having this sort of system of checking, can app server 1 talk to web service 1, and managing those intents that then may drive the controls underneath it of IP address and things like that, that allows you a way to sort of solve that problem in a very similar way using more modern technology that is going to be able to exist within this very dynamic environment. And so the goal for us is sort of living in that multi-cloud reality to build up the sort of service registry that sort of exists in all these different environments, as well as allows you, so not just discovering these different services that live on these different platforms, but allows you to stop maintaining the firewalls that sort of sit in front of these different applications, and allows things like Azure to communicate to service on Azure could communicate to a service on AWS. And what it's doing is it's upgrading the connection automatically to mutual TLS, assuming there's somebody in the middle that's listening. So TLS is our gold standard for traffic encryption. We're going to highly leverage that. And then on each side, it's checking those intents to make sure that this application can talk to this service. And so it's managing authorization that way. Okay, so at the last level, we have a technology called Nomad. And Nomad is really around how do you deploy your application. So in a certain case, in a certain way, Nomad is the scheduler that you would provision apps onto. Now, Nomad is really useful for things like legacy applications or batch workloads. I think is probably the leading use case for it. It also allows you a level of container orchestration, so you can deploy your application via containers, and then Nomad would handle the provisioning of those services into the environment. Now, I think if I don't want to go too far off script, if we think about where Nomad exists today, Nomad is able to schedule to itself. So think about it that when you interact with Nomad, you have maybe a container and a job file and a source code repository. And so you might say, as part of your developer workflow, I have a source code repository. Here's the shape of my application in the form of a Nomad task file. And then, hey, Nomad, go make it happen. Nomad is able to schedule those resources onto itself. And at some point in the near future, it's able to be able to reconcile that against policy. So if, for example, you have services that need to be deployed within, like, let's say it's a German service and needs to be deployed within the boundaries of Germany, you can sort of state as policy, the deployment can only exist within these different constraints. Has to live within the the borders of the country. That's one type of that's an example of policy that we'd be able to add within Nomad for those types of deployment constraints, mainly for compliance. In the future, I think where we're sort of going with Nomad is really around deploying safely across regions, providers, as well as different services. So I think when you think about deploying an application, chances are you're thinking about deploying your app on top of an EC2 instance or this on-prem sort of vSphere instance. We'd also like to be able to add things like Lambda, so that way you can deploy your code, your serverless code with Nomad. Nomad would deploy it onto Lambda for you or Azure Cloud Functions for you, and at that point, it's just Nomad just making sure that those things are still running, and if something were to happen, it can redeploy it for you somewhere else. And so I think ultimately, the reason why we're having this discussion is really around application delivery. Now, we sort of talked about each of those different layers sort of below the stack. So whether that was provisioning in terms of Terraform, offering that common API for your provisioning team to then expose as a consumable API platform. Maybe that's your security team offering either encryption as a service or just a way to sort of centralize how those secrets get requested and pulling secrets out of source code to make your environment more secure. How do we then connect applications? So then offering Consul as a shared service where now you're able to create the service registry that exists across cloud platforms, but it also allows you the opportunity to sort of integrate a more identity-based services approach in the future and sort of get rid of your not only load balancers, but also firewalls kind of in the mix. I think that is one of the stronger goals of service mesh. And I think lastly, sort of recognizing the heterogeneity of the application types, and with Nomad deploying to either Docker directly, Java jars, maybe you're deploying on top of Kubernetes. Nomad can sort of look at those different environments and deploy your application on top of them, in addition to things like a Lambda or a traditional EC2 instance. And what really separates HashiCorp from, I think, the other providers in the space is that we take policy and governance very seriously, and it has a very strong integration point with each one of our technologies. The reason being because in addition to each of these teams sort of exposing an API that makes it really easy to consume either networking infrastructure, provision infrastructure, or security secrets really easily, we need to be able to add the capability for your risk and compliance groups to sort of integrate with those, so that way Terraform, you can't just deploy whatever you want. It's sort of checked against policy that's in there as code. Same thing with Vault. You can sort of maintain how long do keys exist, when do credentials get rotated, and sort of managing those automated rotation of credentials. You can say the same thing about Consul. I mentioned how the different applications, sort of the endpoint of Consul is to provide service mesh, allowing those different applications to check a central registry for, is my application A allowed to talk to application B? I think that's it. So I may have gone a minute over for the presentation, but I think that concludes the presentation portion. And I know that there's a couple questions in the chat. Lynn, if you could help me out just a little bit.
Yeah, thanks, Brent. There were a couple questions. They were very product specific. So one of the questions was with Consul, does it keep track of which service uses what IPs and then update firewall rules that are IP based, or does Consul act like the firewall? I actually have the answer to this question. Happy to answer this one. Console does both. It can update the IP table for firewall rules, or it can also replace firewall to restrict access with intentions.
Yeah, if I could just add on to that, Lynn, so that is correct. I would also say like one thing that customers are looking for is as services get spun up, can we integrate with an existing environment, sort of drive those automated firewall changes? That is absolutely something that Consul is capable of. And I mentioned how each of the technologies has sort of an ecosystem around it. Definitely having like, things like Palo Alto Networks and, Cisco and F5 sort of within that Consul ecosystem allows Consul to sort of publish, hey, like this IP changed, or I have a new service that's on board, and allows those different platforms to say, okay, well, Consul published this new IP. I'm going to consume it and then update my services.
Thanks, Brent. There's another question related to console integration. So you actually touched on this with Palo Alto. So someone asked, does console integrate with traditional NGS like Palo Alto, et cetera? So maybe we want to dive deeper into that topic.
Yeah, absolutely. I think like there's a whole this separate presentation just on like the Consul ecosystem, right, to be fair. I mean, it is, like I said, a goal of every single one of the products to not just sort of live by itself. Like, candidly, each of the HashiCorp products, I'm not going to say they're useless by themselves, but they're very strongly dependent on having a strong ecosystem around them to make them really functional in every environment. And so, yeah, absolutely. Traditional on-prem infrastructure, definitely a target for Terraform, as well as you could say the same thing for Vault, having plugins for things like, Microsoft SQL, MariaDB, MySQL, Oracle, basically every database you can think of, as well as all these different identity platforms, like I mentioned, Azure AD, Amazon IAM, Google IAM. I think LDAP, Kerberos is on our roadmap. So I think like having all those different sort of identity platforms being able to plug into as well. And Consul is really the last layer around having those different plugins around, how do we drive infrastructure automation for those, more on-premise tools.
Great. The next question is, with large enterprises utilizing Apigee for API management, how do HashiCorp solutions fit in with it?
That's a great question. So we just announced, not that it's relative to Apigee, but I do think when it comes to east-west, we talked about how Consul sort of solves that problem. When it comes to north-south, how people or how customers come into your environment and how they would sort of get loaded across your different infrastructure, that's really the job of an API gateway, right? Because API gateway will sort of figure out what version of API you're trying to hit or your customer has access to, and then ferrying you over to the other service. So we have announced integrations with things like DataWire, for example, and Ambassador, right? So I don't think we've announced anything specifically with Apigee, but I do know like that API management and API integration, very important for as customers come in north to south, how do they get loaded into different services? That's another area where I think we're going to see more announcements. Like I said, the first one was around Ambassador. How do we get more API managers or that API management layer sort of involved in the infrastructure, so that way as we're re-provisioning or redeploying applications, it's automatically routing traffic for us. So yeah, absolutely, great question. We'll have to follow up as far as the Apigee integration, but I do know there's other ones that we've just announced, and there's a whole slew of them on our radar for announcement.
Yeah, lots of integration questions here. Someone's asking where we can see the list of console integrations similar to Terraform providers. If I may, there's actually a section on our website, hashicorp.com/partners. And on that page, you can go to integrations and filter for console, and you'll see Datadog, DataWire, pivotal, et cetera, et cetera. And as Brett mentioned, we're on the road to announcing a couple more Consul integrations. So,
Yeah, absolutely. So like if you go to hashicorp.com/ecosystem, that's sort of, you can look for like, obviously the various public cloud integrations are there, partner sort of, I don't want to say partner integrations, but like services partners are listed there, solutions providers, and that's what they're listed as well as product integrations, most importantly to your question. So those have like, for example, all of the on-prem and what they look like and what products support them. They're all there on that integration page that Lynn mentioned.
Great. If there are no more questions, you're going to end the webinar. It looks like that was the last of the questions. Going once, going twice. Okay, everyone. Thank you for joining the webinar. Thanks, Brent, for hosting. Just a couple of reminders. This webinar was recorded, and we will send out the recording and slides usually within 1 or 2 days. And with that, I think we'll close out if there are no more questions. Brent, do you have any closing remarks?
No, I think I mentioned everything product related here. I think I just offer like, because I was on today, if you'd like to email me directly, bholden@hashicorp.com, or you can find me on Twitter at Brent Holden. It's probably the easier way to reach me. I think my email, like everyone else, is pretty clogged. So that's it.
There is a last question if you do want to answer it.
Sure.
That was a little different from Istio.
So I think, I mean, another great question, right? So some of the background that I think the folks on the phone wouldn't have for me is that I was at Red Hat for a very long time. Obviously, a very key product for Red Hat now is OpenShift, and Istio is one of those technology integrations. So Istio is not bad technology. I think it's very good. I think there's a couple of challenges with Istio. So one is it's not production ready. There are no vendors currently shipping it. To be fair, you name it's sort of everyone working on that technology. They're still trying to work out how does the architecture scale. I think it's the number one problem. The second problem related to Istio is that the things that Istio does and the problems it solves are really sort of scoped within Kubernetes. And I think that's a very consistent approach to the entire Kubernetes sort of ecosystem, which is when you deploy an application within Kubernetes, the CI/CD pipeline and sort of Knative integration works really well for deploying apps within Kubernetes. But then how do you deploy apps that live outside Kubernetes? I mean, I have very few customers who have sort of adopted K8s as like they're 100% all in. I think it's a portion of most customers' infrastructure. So I think Istio is not a bad integration for solving your Kubernetes problems. And chances are it's going to become the de facto sort of when you install Kubernetes, it's going to be included. Istio does have a reputation of being very complicated and a very difficult technology integration to manage, especially if there's a problem. In fact, like I was just reading before I jumped on the call, like how to troubleshoot 500 service errors with Istio, right? So like there's an entire sort of cottage industry around troubleshooting it. When it comes to Consul's position in the market, we look at how customers adopt, and candidly, I don't think any customer is going to say we're either all in on-prem or we're all in with Kubernetes on-prem, we're all in with Kubernetes on Google, or we're all in with Kubernetes somewhere else. It's going to be sort of a mix of you're either leveraging the things that Microsoft is producing for the service mesh interface, or you're consuming like AWS Cloud Mesh, or you're consuming Istio on-prem as part of a Kubernetes infrastructure. Those services need to be able to speak to each other. Just like I mentioned how there's these different sort of identity principles with each of these different public cloud providers. I think what's going to happen with Service Mesh is something very similar, which is why Microsoft had that big announcement with Service Mesh Interconnect, which is each of these different providers is sort of creating their own standard for how that gets created and how that gets done. And there was really sort of this need for standardization around it. And HashiCorp and Consul sort of sit in the middle of all that, where it's either it's on-prem or hooking in with this like provider ecosystem for Service Mesh. Consul, the goal of it is to create that ecosystem behind it. And so we want to sit and be that lingua franca of how these different service meshes connect with each other. I think the best example I can give you is that even today, it's possible to deploy 2 different Istio clusters, whether maybe you have like Kubernetes with Istio on Azure and Kubernetes with Istio on top of your on-prem infrastructure. Federating those is a very difficult problem to solve. In fact, that's been on the roadmap for over 2 years. And we have a lot of customers leveraging Consul as sort of the glue between that.
Great, thanks. So that's officially all the time we have for questions, and we will actually officially close this out. So thank you everyone for joining.
Okay, thank you, Lynn. Thank you everybody for attending.